Hello. So for today, we're gonna demonstrate a Python program on the topic of greedy algorithms. This is under the course of algorithms and complexity. So what we have here is a problem, and let's give you an overview. So supposedly, we work at a grocery store to help our parents save money and pay our bills. And at the grocery store, we need to work efficiently to avoid long lines at the counter. And we are being paid on the number of customers that we serve for the day. However, the cash register box only contains a limited amount of money and will be only refilled once a day. Now, for us to be able to cater as many customers as possible, so we need to be efficient, and we need to give each customer an exact amount of change with the fewest number of bills and coins. Now here are the table. Uh, so the column here on the left uh, represents the prices to pay for each transaction, and then on the right column corresponds to the payment per transaction. Now, for example, the first transaction, we have a price to pay of 1,724.75 pesos, and the customer paid uh, and me, the cashier, 1,000 pesos. And we need to give the exact change for that with the fewest number of coins and bills. So you should answer these questions. Number one, the cash register box has the following denomination: a 5 cents, 10 cents, up to 1,000 peso bill. And then with the answers from number one, we should get the total number of fewest coins or bills for each changes per transaction. So let's proceed to the code. So what we have here is the Python program that we made for this specific problem. So we're gonna use the greedy algorithm. So let's discuss this one by one. So this one, we need to define the denominations of bills and coins. So we have is a thousand peso bill up to 5 cents. Now, the next thing is the function. So we have here a function, calculate change, with two parameters, a price to pay and the payment. This one, it will get each parameters from this list here. So we made a list for each price to pay and their corresponding payment list. And then under the calculate change function, we need to get the change first. So payment minus price to pay, so that's the change. And then we'll create a dictionary for each of those changes. So the dictionary has the keys of change, and then the values of it are the list of denominations for the change. So example, have a key value of the change of this one, first transaction, and then the values is a list of all of the denominations of that change. So this one will look through the available bills and determine the count for each bills funds on this one. So then it will return the result of that. Now, this is the list as I've said earlier, and this is the per printing of the transaction. It will gonna do uh, this code for each transaction that we have. So we have back there five transactions. So this one it will gonna get the price, price to pay, doing the payment, then it will call the function, then it will print the transaction number, then print the change. It was broken down into each of the denominations, and then the total change. So let's try to run this code. Let's see. So for transaction 1, we have a price to pay of 1,724.75 and a payment of 2,000 pesos. If we calculate the change of this, it should have a 275.25. How do we broke this down into the smallest or fewest possible coins and bills for us to give to the customer? We have this here, change section. So the 275.25 can be broken down into 1 200 to bill, 1 50 peso bill, 1 20 peso bill, 1 5 peso coin, and 1 25 cent coin. That's the optimal or efficient way to give things to the customer. Now, transaction number 2, same thing. Price to pay 1,652.55 and a payment of 1,700 or 1,700. And the change is 47.45. So broke this down into 220 peso bill, a 1 5 peso bill, 1 peso coin, a 25 cent coin, and 1 cent coin, a 10 cent coin. And then the same goes for remaining transactions. So 1.8, 1.15, a payment of 520, a change of 11.85, so a 10 peso coin, a 1 peso coin, 3.25 peso coin, so 0.75, and then to top it all up, the 10 peso coins, so a total of 11.8 change. Transaction 4 and transaction 5. That's all for this demonstration of grid algorithm. Thank you.